Hello once again, class, and welcome to another mock lecture. In today's video, we are going to talk about one example of problem solving with geometry. Let's get to it. Alright, suppose it takes 75 50-pound bags of soil to fill a 2-foot high circular planter. It's got a diameter of 8 feet, let's say. How many bags of soil would be needed for a 1.5-foot high planter with a 5-foot square base? Now you might be wondering, when would I ever run into this situation? Well, pretend your friend comes up to you and says, listen, I know I bought 75 bags of this 50-pound bag soil for my 2-foot high, 8-foot diameter circular planter. How can I use that to help me figure out what I need for my 1.5-foot high, 5x5 square planter? And you can say, I got you, bro. First thing that comes to my mind is that we should set up a proportion equation. We know that it takes 75 50-pound bags to fill the volume of the circular planter, which I've abbreviated here as volume sub CP. And if we set up the proportion with bags in the numerator and volume in the denominator, then we'd have some unknown quantity of bags in our second ratio and the volume of the square planter in the denominator of our second ratio. So fundamentally, I need to figure out what the equation is, what the solution is for this double question mark here is. To do that, though, we're going to need to calculate the volume of each of the planters individually, which luckily, since they're given in the same unit of measure, we know it's going to be cubic feet for both of them, and I'll explain why that's the case in a little bit here. So first, let's focus on the volume of the circular planter. To calculate the volume of a cylindrical prism like this, we know it's 2 feet high and we know that it has a radius of 4 feet because its diameter is 8 feet. There is a formula to find the volume of a cylindrical prism, and that volume formula is pi r squared times the height. So we get pi times 4 squared times 2, right? So the radius is 4, it's half of 8, 2 is its height. We do this multiplication, pi times 16 times 2, so 32 pi is what this is. And you're going to get approximately 100.53 cubic feet. Now, how do we know that it's cubic feet, though? Well, the radius is in feet. Squaring the unit of measure for the radius gives you feet squared. And then you're multiplying by a height, which is also in feet, so you get feet times feet times feet. That's feet cubed, right? That's cubic feet. That's why we get cubic feet as the unit of measure for this. So I'm going to go ahead and fill out the first ratio with 75 bags of this 50-pound soil divided by 100.53 cubic feet. All right, we just need to figure out what the volume of the square prism is. To do that, we know that the dimensions of the square planter are 5 by 5 by 1.5. The volume formula for a square prism like this, square-based prism, is you take the side length, which is 5 in this case, you square it, because length times width times height, length and width are the same in a square prism, and then you multiply by the height. So we're going to get 5 squared times 1.5, which is 37.5, again, cubic feet. This is 5 feet times 5 feet, so you get 25 squared feet, but then you're multiplying by 1.5 feet, and that's where you get the cubic. That's where the cubic unit comes into play, so we go ahead and fill out the second ratio. Now I'm going to strip everything away except the proportion that we're looking at here, and I just need to solve this. You can think about this as your variable. You can call it x if you'd like to. X is being divided by 37.5, so what we need to do is we need to multiply both sides by 37.5 so that we can cancel that out. But whatever you do to one side, you have to do to the other, and that's what I'm showing here. Multiplying both sides by 37.5 cubic feet is going to go ahead and cancel out the 37.5 cubic feet on the right ratio, just straight up. We're just going to be left with this thing in the numerator on this side. On the left-hand side, stuff cancels, but it's only the unit of measure, right? Only the unit of measure cancels here, and so we get this. 37.5 times 75 bags is our unit. It's our only unit that's remaining, which is good because that's what we're trying to figure out, how many bags of soil would be needed. And we divide that by the 100.53, which was originally cubic feet, but that canceled the cubic feet from the 37.5 cubic feet. Running all this into a calculator gives you approximately, that's what this symbol means here, is approximately 27.976, and then a whole bunch of decimal stuff after that, bags of soil. Now, you can't go to a store and say, I'd like to purchase 27.976 bags of soil, right? You can't just chop off a part of a bag of soil and say, I'm not paying for that part because I don't need it. You would, in fact, have to buy 28, right? And in the context of this situation, that means that we need to buy 28 50-pound bags of soil. And that's it, right? That's it for this video. Just one example. Hopefully that was helpful. I just wanted to show you how to do some problem solving with geometry. We used volume in this one. If you have any questions, shoot me an email or leave a comment below. Thanks a ton for watching, and I'll see you in the next one.